So how an electron microscope works is that for an electron microscope, we need a beam of electrons. So an electron is extremely lightweight. It's negatively charged. It can either be bound to an atom or it can be free-flowing. There are a lot of manipulations required for an electron microscope to do its job right. The electron beam is created by a lanthanum hexaborate crystal. Now, this is a metal when it is heated to a very high temperature and subject to very high voltage will emit a strong beam of electrons. And that beam of electrons now needs to be guided along a path so that it can shine down as a single beam on the sample. And that is done by a series of electromagnets. And what is an electromagnet? It is a copper coil, and you bombard it with an electric current such that it creates an electromagnetic field. And because electrons are negatively charged, they react in this electromagnetic field and they can be manipulated to create a nice beam that will then shine on your sample and help us to create an image. So the light and the electron microscope are very similar and different. The difference is that in the light microscope, you use a beam of light to shine on the object. In an electron microscope, you use a beam of electrons to shine down on the object. In electron microscopy, there are two different types of electron microscopes. One is a scanning electron microscope, and the other is a transmission electron microscope. The scanning electron microscope, as the name suggests, the beam of electrons scans the surface of the sample and gives us an image of the surface view. So it's a three-dimensional view of the actual object that you're scanning. In a transmission electron microscope, the electron beam goes through the sample, and that's where the image is generated by all the areas in the sample that allows your electron beam to go through. And this gives us a more detailed image of the inner structures of a sample. So the scanning and the transmission electron microscopes both have a very high level of magnification. The scanning electron microscope can magnify samples about 1 to 2 million times, whereas a transmission electron microscope can magnify samples up to 50 million times. This allows us to really visualize cells in their detail structure. And so the scanning electron microscope can, for example, show you an image of the actual surface structure of a cell, versus a transmission electron microscope would give us an image of a slice through a section of a cell, giving you details of the organelles inside, like the nucleus, the mitochondria, the endoplasmic reticulum, and other fine organelles that are there within the cell. Every day when I turn on that electron beam and look into the microscope, it's a whole new world that's revealed. One moment it was an invisible, obscure world with it had nothing in it, and then the beam just shows you something new that sprang to life, and then it's another magnification and something that you didn't see a second ago is visible. And it's just amazing to see that the magnification it brings to your eyes the wonder, the organization, the structure, and each of these things have got a purpose and a function that they perform to keep all our systems going. And the fact that we are able to capture that bit of wonder with the electron microscope is what kind of keeps me ticking and keeps bringing me back to work every day. And it's a world that's just waiting to be tapped.